Good morning, good afternoon, and good evening, depending on where you listen to the podcast. Welcome to The Writing Glitch, Hacking Dysgraphia, no pencil required. I'm Cheri Dotterer. I am the host, and I am at cheridotterer.com. That's spelled CHERIDOTTERER. Today's podcast is a special event. This is a masterclass that we did back in December of 2021. And if you would like CEUs for the podcast, the link will be in the show notes. The cost for the CEUs is $19.99. It really has been the foundation of the book that is coming out later this year that Jonily Zupancic and I are writing. Hey everyone, Cheri Dotterer here with Jonily Zupancic. Welcome, Jonily.
Hello, thanks for having me, Cheri.
When we talk about math, we talk about this thing called number sense. And I was like, I don't understand what that means because it was a foreign word to me. Also, we have problems with math facts. Now that I understood because we hear all this time about multiplication tables and stuff, and they have to do those in those time tests. But I didn't understand the connection back to number sense. So also have trouble with calculations and magnitude relationships. They might count on their fingers. They might switch procedures. So, they might be supposed to be adding and all of a sudden they're subtracting, or multiplication and division. They get it all mixed up. Math concepts are facts, and then quantitative problem solving. But that still didn't give me a good, clear understanding of the differences between dyslexia, dysgraphia, and dyscalculia, and some other diagnostic. Is it the same as ADHD, and what makes it similar or different? It was really a little confusing. Let's go back and really understand what number sense is. Jonily, could you explain that?
Yes, so we wanted to pause here after looking at what the DSM says about what to look for as far as student struggles. A lot of times we see students that struggle and we know what some of those things are. I'm going to talk math specifically. I know from my line of work that students that struggle in mathematics overall have a weak number sense. So let's talk about what number sense is and what number sense is not. And this might kind of shake up your definition of math and math facts, but let me kind of lay it all out here, and then we'll use this definition as I go through some of the strategies a little bit later. So number sense is intuitive, it's innate, it's something that we are born with. Johns Hopkins University published a research study in 2011 that really looked at the magnitude of numbers. What is magnitude? Magnitude is exactly what Cheri said. It's how large or small numbers are given a set of dots or a set of objects. So what Johns Hopkins University did to figure out that we are born with a certain level of understanding of number is they assessed 6-month-old babies, which is hard to believe, but they did it with a bunch of dots and a few dots and watched for their eye movement. I'm not an expert in this. You'll have to look up the study. But based on their findings of how 6-month-olds responded, they knew that we are born with a certain level of understanding of number. As we become toddlers and get into school-age years, a stronger number sense affected the way that we had access to mathematics. So number sense is also quantity of number, meaning value of number, the size of a number, the placement of a number on a number line. It's also understanding the comparison of numbers, which number is larger, which number is smaller, how far apart numbers are. But it is not procedure, step-by-step math facts, just knowing a recipe, a formula, an algorithm. All of the things on this chart that says number sense is not, I'm going to call that category math ability. Math ability is the math that we learn in school, are the quick facts. Math ability are the procedures like long division or double-digit multiplication algorithm. So all of those things that are typical traditional math that we were probably taught is not what I put in the category of number sense. That is the category of math ability. So number sense is this innate intuitive understanding of how large or small numbers are. So based on the number sense definition, the math ability definition and examples, there are two camps, and I'm going to refer to these a little bit later. There's the number sense camp that I'm going to call conceptual, and there's the math ability camp that I'm going to call procedural. So that is the foundation definition that we're going to be working with tonight. You may agree or disagree with that, but that is the working definition that we are going to use tonight, that I will make some points later with our strategies.
You said something very early on in that explanation of what number sense was. It said that 6-month-olds, they were looking at the way they were looking at things. So when I think about that as an occupational therapist, I think visual scanning, being able to focus and concentrate, and all those things like mental wise and ocular motor wise that are affecting a student's ability to engage in their education. So if they are really being able to attend, focus, visually scan at 6 months old, what are they doing when they're in elementary? Are they still struggling with that, or has something gotten better that makes that a little bit easier down the road? Or are these the students that continue to struggle and are just still struggling even though they're entering elementary?
Johns Hopkins University says that if they're struggling at 6 months old and at toddler age with these assessments, they're going to continue to struggle unless we find strategies to improve their number sense. If we can do that with the specific strategies I'm going to share tonight, their math ability will also increase and they will have less struggle later on.
Interesting. So do you need to really go into a little bit more about what number sense is not?
No, I think I covered it, but what I just want to review is number sense is conceptual, innate, understanding value and how large or small. The other camp is math ability, which is procedural, and that's everything that number sense is not. So there's the summary. Procedures and concepts are not competing interests. Both are essential, both are important. What we want to do when we're providing interventions or providing instruction is have a balance of procedural and conceptual mathematics. I'm going to give a few examples in just a moment. And if I am teaching procedural step by step, I want to make sure that I'm using explicit direct instruction. Research shows that especially for special ed students, that they need explicit direct instruction in order to master, I'm going to say mathematics, but I'm going to narrow that down in just a moment. I agree with that, and that is completely true when we are teaching procedures. But teaching explicitly and directly is the barrier to improving conceptual understanding and improving number sense.
Whoa, wait a minute. Repeat that again, because that is totally foreign to everything that I've been taught. Say that again.
Absolutely. So when you think about typical traditional mathematics, you have procedures, you have step-by-step processes, you have adding 3-digit and 3-digit numbers, subtracting a 3-digit from a 4-digit number. You have 2-digit by 1-digit multiplication. You have the long division process. All of those step-by-step processes are what I'm going to call procedures. And let me give a graphic. I'm going to actually put proceed on this vertical continuum. So on this vertical continuum, I'm going to call this procedural or procedures. And I also gave this another name, which was math ability. All of this and the examples that I gave is what typical traditional school math is. Probably the way all of you watching learned mathematics. The teacher modeled step-by-step a process, and then you were given 4 or 5 examples to mimic. There is nothing wrong.
So what you're saying is, like, 5 plus 5 equals 10, or 5 times 2 equals 10, 2 times 5 equals, those are all procedures.
Those are all procedures, and some of those are just quick facts. Some of those are just math facts. So
Okay.
if I say, what is 3 times 4, and you just know it's 12, I didn't have to do any procedure, I just know it. So those quick facts also fall in the math ability and the procedure. There are students that are really, really good at this.
So those timed tests that we're talking about, those facts are procedures that we need to just know. So kids that have problem with the dyscalculia have difficulty with the just know.
Absolutely. They have difficulty with it. I am going to do is focus on this other camp, which I'm going to use this continuum to explain. The other camp, as I called number sense, so number sense. The other word I used is conceptual. So number sense conceptual is that innate. If I want kids to estimate, they can estimate well. You know, that's not necessarily that's a skill that's very difficult to teach in a procedural way. That's a skill that's very difficult to teach in a step-by-step, explicit, direct way. So this is the opposite of math ability in school math. I call it number sense and conceptual understanding. So, and this is where Cheri asked me to repeat this. Research says that especially students with math difficulties and students that have learning disabilities need explicit direct instruction. And that is true if I'm teaching a procedure, if I'm teaching a step-by-step process. Kids need explicit direct instruction. Explicit direct instruction is the barrier to improving number sense and conceptual understanding of mathematics. Explicit direct instruction is the barrier to improving number sense and conceptual understanding of mathematics. So when we continue to give these explicit direct instructions, we are negating, we are eliminating this increase in student understanding of numbers. So the big question that we're going to answer tonight is, how do we improve number sense and conceptual understanding? Because when this improves, this also improves. Just like the Johns Hopkins University research study, students that had a strong number sense when they were 6 months old, toddlers, the number sense that we're born with, did not have as many difficulties in school math. So if we can focus on improving this piece will increase as well. What I've done in this graphic is I've created 4 categories of math learners. This category that I call quadrant 1 is strong number sense, strong math ability. These are kids that have both of those things. This quadrant that I call quadrant 2 is weak number sense. Those are those kids that don't understand innately how large or small numbers are, but they can do school math really well. This quadrant of students I many times call false positives because they play the math game well in school, they mimic well, they might memorize well, but deep down, if we start doing some of the exercises I'm going to share tonight, they don't have a number sense or conceptual understanding. We want to move these kids to this quadrant.
So if we relate that to the DSM-5, their activity demand, their academic demand hits that ceiling and they have struggle. So they can only go so far before they go, well, I don't know.
Absolutely. Absolutely. Okay. Now, if we look at the kiddos in this quadrant, which I'm going to call quadrant 4. Don't worry about the names of the quadrants, but this would be quadrant 4. I've skipped quadrant 3. These are the kids that have a strong number sense, but don't do well in school math. Maybe they don't do well on assessments or tests, And I call these kiddos many times false negatives, because these are the kids that sometimes teachers will recommend that they need math intervention, but the teacher just doesn't have the skills to extract this type of understanding. These students actually know more than what our types of assessments and tests are gathering from them. So that's why I sometimes call these kiddos false negative.
So give us an example of what that looks like.
I'm going to come back to those specific examples when I share the strategies. Can we put a pin in that?
Sure can.
Perfect, because this is the quadrant I think everybody can understand, quadrant 3. These are the kiddos that have a weak number sense. They don't understand how large or small numbers are. They also struggle in what I call school math or with math ability. They don't do well on assessments, tests, but they also don't have that innate sense of number. That's the opposite of these kids, where these kids don't appear to do well in school math, but they actually have a good sense of number. I'm going to give you a couple of examples of what that looks like. What does a good sense of number look like with the 3 strategies we're going to focus on tonight?
So as you were talking about that, I was thinking about letters, thinking explicit instruction versus innate understanding. And those kiddos that need extensive remediation to understand, I'm going to use the simplest letter that's out there, and that's the capital letter L, where it's the vertical line down and then the horizontal line. And probably it looks backwards from where you're standing, forgive me. But that they innately, like, they see it the first time and they get it. I'm thinking if we relate back to Johns Hopkins, those are the kids who can visually scan well. They're vertical. So they're also innately get much more understanding of symbols that represent words.
Absolutely.
So then the kiddos that falling into the bottom half of your drawing there are the kids that need a little extra support. Now the kids that are in your right side of your quadrants there, they're the ones that with a little bit of remediation, all of a sudden it's like, boom, they got it. When those ones that are on the left, you feel like you're not getting anywhere over the entire school year.
And these kids definitely need different instruction, and that's what I'm going to focus on and share with you tonight.
Wow, I sure have a new understanding of number sense. The rest of the podcast episode is going to be Jonily's first strategy, rote counting. The rest of her strategies will be in the full masterclass that you can gain CEUs. Look for the link to the CEUs in the show notes.
And rote counting is counting without any kind of meaning. Now, you might think, well, isn't that how you described procedural? Well, rote counting, I don't know that it really falls in any of these categories here. So now I'm ready to give you some examples of procedural, conceptual. Rote counting is kind of a thing of its own. I'm not doing rote counting with any kind of procedure. It is kind of a mimicking kind of thing, but I'm also having kids use their innate understanding of counting. Toddlers can rote count by 1s, 2s, sometimes 10s. In a real sing-songy way. If toddlers count 2, 4, 6, 8, who do we appreciate? They may not be able to identify 8 items, but they can just count without meaning. So that's the exercise that I want kids doing a lot of. We're not going to worry about how big or small numbers are. We're just going to have them rote count. Now, here is the procedure, the process, the sequence for instruction to give kids experiences with rote counting. Where it says 1s, I like for students to count by 1s forward from any of these numbers. So if it says count by 1s forward from 1, I'm going to have students count 1, 2, 3, 4, 5, 6, 7, 8. I'm going to stop them. If I want kids to count forward from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. I also want kids to count by 1s forward from 8, 8, 9, 10, 11, 12, 13, 14. So the starting number is important, and I'm going to skip to the number 29 that's listed here. The reason I give all of these varieties is we can't just assess whether students are able to rote count by ones forward unless we have a variety of numbers that they're starting with. Because if I ask students to start with the number 29, the reason for this is, do they know that 30 is next? And that is difficult for kiddos.
It relates back to sequencing of the alphabet, where I try to get kids to start at like the letter H and do the next one or two letters. And then we get to elemento, which is one letter, they think. But so I see that also relating back to letters.
The typical student, it's very difficult to count backwards. And that's why many students struggle with subtraction. And we have to have specific interventions to help kids understand subtraction, because part of subtraction is counting backwards. Now, we can modify that. We can change the meaning of subtraction, which I'm not going to get into, but counting backwards is one of the facets of subtraction. The next thing that I want kids to do is count by ones backward. And I'm going to start here with 10. 10 is usually pretty simple, especially for kindergartners, because they can count back like a rocket ship. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I will say keep going to see if they know that 0 is next. I will also say keep going to see if they know that negative numbers, and I do have kindergartners that know that negative numbers come before 0. So when you're counting backwards, after I say 0, I say negative numbers. 2 reasons I'm having kids count backwards. The more strength a student has in counting backwards, the higher their number sense. So I'm doing a lot of assessment here. I'm doing a lot of exploring of what kids know. I'm judging how strong or weak their number sense is. If they're able to count forward and backward from any of these numbers by ones, the more they're able to do that accurately, the stronger their number sense. So this rote counting is a good exercise to improve their number sense, but it's also good for the instructor to see how strong or weak their number sense is. Then I do backwards from 12, because from 12, I have to go past 10. So it's more difficult than starting at 10. Then the reason I start at 18 is because the teen numbers are tricky. When we say 13, 14, 15, 16, 17, 18, it follows a language pattern. But 11 and 12 are 2 words that don't follow the pattern that has teen in it. So the reason I start from 12 is I avoid those numbers that have teen, because it's a different assessment. And the reason I start from 18 is kids can pick up on that pattern, 18, 17, 16, 15, 14, 13. They will a lot of times struggle with going from 13 to 12. And those are things that I want to know. Students that can do it accurately have a stronger number sense. Students that struggle with that have a weaker number sense.
Okay, so I want to stop there. I want to go back the other direction going forward, because I get a lot of kids that'll go 11, 12, 13, 14, 16, 18, 20. And they'll have those trouble in the teens even going forward. What do you see as a math teacher in that realm? Or is it because I'm seeing a lot of kids with the disabilities that I get that?
No, that is a typical struggle. The typical struggle very early on with young students, not so much when we get to 4th and 5th grade and beyond. Kids fill in those gaps on their own. It's not a real typical struggle then. But it's also a struggle when we're starting at 98 and counting forward, because kids don't have a concept sometimes of what number comes after 99. So if we count 98, 99, now we're into a 3-digit number. So sometimes they skip that and go right to 101. So very typical that kids are skipping number. Why am I having them rote count? Because the more they rote count, the better they're going to be. Their number sense is going to improve. What I don't want us to do is get frustrated with them when we're first starting to have them rote count, because they are going to skip numbers. They are going to struggle, and it's okay. I want to just assure them it's okay. I don't want to necessarily correct them every time. I want to just do the rote counting again at my next interaction with them. The minute I start correcting them and telling them exactly what's next, I'm turning this into a procedural type of instruction. And I want kids to just experience rote counting. That doesn't mean there's not a time for procedural and explicit instruction. But right now, when I'm giving kids experiences with rote counting, I'm just seeing what they can do with it. I'm documenting what they say, what numbers they skip. And over time, as they rote count, they're going to start to fill in those gaps.
And I really am having trouble with these students getting from the point of being able to figure out the next step on their own. I just have to force the procedure to them for them to get to the next part.
So with rote counting, I'm not necessarily fixing. Now, the other thing I like kids to rote count is just rote count by tens. Many kids, especially struggling kids, they can do this pretty successfully. 10, 20, 30, 40, 50, 60, 70, 80. They actually are pretty successful.
But they don't necessarily know what they're doing.
They don't know what they're doing, but they can do it, and they have this innateness about what number comes next. 2s, 2, 4, 6, 8, 5s, and 20s. Those are some of the simplest skip counting numbers that even students that struggle find some success in. Now, this is where it gets tricky. I know that a student has really strong number sense. So Cheri, you asked me a little bit ago, I'm having a hard time wrapping my head around, what a strong number sense looks like, or what these examples might look like. With rote counting, this is where I can really assess how strong or weak a student's number sense is. I ask students to skip count by tens from 0, 10, 20, 30, 40, 50 is what that means. But I have them start at 60. You see this on this slide here. 60, 70, 80, 90, 100, and I say keep going. Students with a strong number sense, even as young as kindergarten, if their number sense is strong, and this is something that's never been taught to them, this is what I mean by innate. Kids just know how to do this, and a lot of times we can't even explain it. With a strong number sense, they'll be able to count 60, 70, 80, 90, 100, 110, 120, 130. Kids that have a weak number sense will count 60, 70, 80, 90, 100, 101, 102, 103, 104. I'm always evaluating how strong or weak students' numbers are, so I know how often and how many interactions of these interventions kiddos need.
So I'm going to pause here just a minute, because what you're doing, a lot of that is oral. So when we go to write it down on paper, I see a lot, even if they get it orally, what I would see down on paper would be, instead of them writing 100, 110, they're going to write 101. The oral is going to be first because it's the easier pathway to develop, then the written pathway is going to come in.
Now, let me say this too. If we are talking about the number 17, kids will often write 7-1 because the 7 comes first, and they write that. Now, no longer am I talking about interventions to improve number sense. That has nothing to do with it at all. All of the rote counting is oral. That's how I'm going to assess their number sense. The minute they write down a 7 and a 1, I'm going to go to explicit direct teaching. I'm just going to say, it's not a 7 and a 1, it's a 1 and a 7. Do you see, that's the difference between giving them an experience to improve their number sense, and then now all of a sudden when we're writing numbers, they're not going to just discover that type of thing on their own. Rote counting, they will eventually discover which numbers come next because it's a conceptual intervention. But when I'm writing numbers and kids are struggling with writing numbers, that's an explicit direct instruction. Have them trace, I'm going to have them mimic me, those kinds of things. So you start to see the differences between this type of instruction and this type of instruction.
Okay. So before you go on, I'm looking at your next two numbers, and that's 24 and 37. In my brain, I'm thinking about a set of brothers. One of them's in 2nd grade, one of them is in 7th grade. And I'd be willing to bet that my 2nd grader is going to be able to figure out 24, 34, 44 much quicker than his older brother, who has different situations, but they're both have disabilities. Not sure that the younger one is going to get the 37, 47, but without having a visual cue.
So let's talk about this. So that's exactly what I want kids to do. I'm going to say to them, I want you to skip count by tens again, but I want you to start at 24. A kiddo that has a strong number sense is going to be able to do 24, 34, 44, 54, 64. They're not even going to be able to explain how they're doing it. They just know. That's that innate understanding. A kid that's kind of a middle of the road number sense, this is how they will answer. So it's not real strong, but it's also not real weak. They'll say 24, 30, 34, 40, 44, 50. That's actually pretty good. That's actually pretty good for a kiddo. It's not completely accurate, but they're much closer to skip counting by tens from a non-10 number than a kiddo that says 24, 25, 26, or any other random thing that's not even close to that ones digit being a 4.
That's very interesting. And I think that is one thing that we really need to understand. And I think from what you have told me in the past, it's the best wrong answer. And I think understanding best wrong answers and having experience ourselves as the adult doing the intervention with the student, going, oh, okay, so that's a better number sense than if they would go 24, 25, 26, and they wouldn't have any clue how to get to that 10 there. I think those are little cues that would be very helpful for an occupational therapist to understand.
And that's why I wanted to give all of these examples here kind of in order of things that you can do and explain to you what to look for. Now, let me back up for just a moment. If you are a parent and you're watching this as a parent and you're thinking, I really want to see where my kid's number sense is, and then I want to improve it, so I want to do these counting strategies. Part of this I call minivan math. You don't have to have a minivan to do this, but so often there's wasted time when we're driving from home to school or from school to practice or wherever we're going. We have this kind of, wasted time in the car to and from places. This is a perfect time to do some of this rote counting to see where your students are. And this is a sequence of steps that you can take with them to figure out how strong or weak their number sense is and just give them these opportunities for just counting. If you're an occupational therapist and you're pulling students out of the classroom, this is a great exercise to do from the classroom to your office. Have kids rote count as we're walking to the office. It's just a really great way to fill in those time gaps as well. It's a good assessment.
A lot of the schools today have those sensory pathways.
Yes.
That I'm talking. You know what I'm talking about?
Yes.
So we could say before they get on the sensory pathway, I want you to skip count by tens. I want you to start at 24, and every time you go to the next step along the sensory pathway, you say that. Now, that's to say that he knows the sensory pathway well enough that he can get through it. If he's concentrating on what to do next, he's not going to be able to do both. So we also have to realize that we have those situations where the other thing is we could do skip counting down the hallway as they're stepping 24, 34, 44, and see how many steps it's going to take us to get to the OT room.
Love it. Absolutely love it. Now, this next one is pretty tricky. So if you have kids that have a pretty weak number sense, they struggle with math in general, this may not be one of the best ones. We want to get them there, but this is where I want kids to count backwards by tens. And I'm going to start at numbers like 62 and 43. Now, let me give you this because I'm going to tell you, I have first graders that can do this. This is that whole conceptual number sense idea. Nobody has taught them this. Nobody has explicitly told them this. They just know these things. So if I have a student count backward from 62 and they have a strong number sense, they're able to do 62, 52, 42, 32, 22, 12, 2. Now, I will tell them to keep going. And I have first graders that will tell me correctly, -8. What is the best wrong answer if I count backwards? 22, 12, 2. Best wrong answer is -2. Best wrong answer is -2. Best wrong answer is -2.
Yeah.
So we're going to look for that. Another best wrong answer is -12. Another best wrong answer is 0, because kids don't have a concept of negative numbers. Now, I also ask students in 8th grade to count backwards from 62. This will tell me how strong or weak their number sense is. I have students, a good number of students in 8th grade that count 22, 12, 2, and when I say keep going, give the best wrong answer of -2. This rote counting exercise will do 2 things. It will assess how strong or weak students' number sense is, and the more experiences students have rote counting, the more they're going to be accurate, and that's going to increase their number sense.
This has been Cheri Dotterer with Jonily Zupancic reviewing rote counting and number sense on The Writing Glitch. Hacking Dysgraphia, no pencil required. Be sure to check out our other podcast, Tier 1 Interventions. Look for it on your favorite podcast app.